So welcome to another seminar for structural engineers. Today we're doing tips and tricks for Mathcad, also known as Mathcad for Dummies. Of course, Mathcad isn't for dummies, it's for the highly intelligent and highly educated people to compile their calculations in a form suitable for presentation. So at the very beginning, the ribbon, and in common with many Windows programs, across the top of the screen is the ribbon, and it's similar to other Windows programs. And you'll see this one is a ribbon from Mathcad Express Prime. Now the Express version is the freebie version. And when you launch it, you'll be taken to a website to say, please buy a full copy of Mathcad. And because it's the Express freebie version, you get some of the functionality is blocked out. So the solve blocks and chart components, for example, are blocked out. The ribbon is the same regardless of which version. So it's been the same since version 5, 6, 7, 8, 9, and now 10. It's not a great deal different, but this is your starting point, and things are found under each of the menus. So access to most of the function are via menus and ribbons. So we've also got quick links up here to open, save, new, and undo and redo, which are always quite useful, quick tools. More importantly, you've got access to resources, which is the end menu. So let's have a look at that first. Under resources, it's a good starting point. So if you're new to Mathcad, click on the resource menu and you can start with a tutorial, also look in the help file, and even join the community. So begin at the beginning, there is a getting started tutorial, and this goes through 6 exercises. So this is a good starting point for new users to Mathcad. There's also a Mathcad help if you want particular help and advice on a technical issue on Mathcad or how to use Mathcad as well. In the community, there are users of Mathcad who have posted questions and others have answered, so you may even find some of my posts in there. This tends to be the more advanced stuff that you won't find in the help file or in the tutorial. Mathcad themselves, or PTC Technology as they are now, they also do a whole series of videos to get you started, accessible via YouTube. And there are a number of people also making YouTube clips, videos for Mathcad. This is one I'd recommend, a guy called Pat Hefferman. He's also an engineer, and he goes into some details about how to use the various aspects of Mathcad. And of course, there's my good self. There's a whole series of Mathcad for structural engineers, short videos which have been extracted from the longer CPD seminars. So check it out, like and subscribe. So coming back to the left, we have the document panel. And as you'd imagine, it is what you need to set up your document. So Mathcad is really about documenting your calculations as well as doing them. And this is where you can put the size of your printed paper, see what it looks like in the printed form. So you've got page setup, and I recommend over here we reset it to A4 if it's not already reset to A4. It'll often come default as letter size. This is where you can set the margins, the grid lines, the headers and footers, and so on. And I'll be going through an example of that later. You can add in page breaks, text boxes, and text blocks. The difference between a text box and a text block, the text block goes all the way across the page, as well as images. Now, images can be in multiple formats, typical image formats you can insert into your document for illustration. And you can define areas which you can hide and expose as you see fit. Next, we have the calculation menu, and one of the useful tools on it is this button called redefinition. And redefinition is it will declare whether you have used a variable before, and it will circle the variable in green. This is only available in the paid for premium edition and not on the freebie version. but it's kind of quite useful because you can end up redefining variables when you didn't intend to, and that can often lead to complications and errors in your Mathcad. The green circles do print, so before you print you may want to switch off the redefinition warning sign. Moving along to the left, we have text formatting. And as you might imagine, this is where you format the text. So the style, size of format, colors, and so on. And more importantly, there's a spell checker, and you can set your proofing language. And again, the spell checker is only available on the premium edition and not the freebie edition. I suggest you switch it on because many of us engineers are not that great at spelling. Moving along, we have math formatting, which is, as you can imagine, where you format the maths, i.e. the equations. So the style and the size and the display of the equations and the numbers you're using in your calculations. Styles and sizes for your equations. You can also set the number of decimal places and whether you want it in engineering form or decimal form. Plots, moving along, as you can imagine, is where you put your little graphs. And you can produce many sorts of graphs available through the plot. And simple line graphs is readily available through the plot menu. This, I think, is parallel to the charting tool, which we'll see later. This is a much more basic one and could possibly be more useful for calculations as you go along than the final finished calculation report. To the left again, the matrix and tables. This is where you insert a matrix or a table in your calculation. So we've seen these examples before. So on the right-hand side and at the top, we have two arrays, and these are basically one-dimensional matrices. And using simple matrix multiplication, we can develop the load span table for these fixings in this case. The point of this, you need to understand matrix algebra, matrix mathematics before you use it. Not really for dummies, I would say. It's not something you should start out doing. But once you're established with Mathcad, then by all means head into the matrices. Tables are also useful for defining arrays of variables. I could have easily declared that as a table in terms of span, and that will allow you to declare a variable, give it a unit and a number of values. And this is where it's been used, so I won't click on that. That will take you to the YouTube version of that particular CPD seminar. Moving along, functions. Yeah, not for dummies. Most of the functions are only available to the Prime version, not the Express version. Definitely not for dummies, because you have to understand what the functions are doing, and it's not obvious what they're doing. One function I do use, and it's this thing called solve, and you solve using a find function. Eagle-eyed will spot it. This is an equation from AS 4600 for light gauge steel, and it posits that a value of the buckling stress is given by the result of this equation, one that satisfies this equation. So you could, I suppose, do it by trial and error, but thankfully we have a thing called find in Mathcad, and that will give you a value. You put in a trial value, put in the equation you want it to satisfy, and like my magic, it will pop out the value that satisfies that equation. It doesn't always solve it, I have found. If you've got a very complicated equation, it will return possibly an error. Moving along, and we have the input and output, which is mainly to do with Excel. Some of these functions are only available on the Premier Prime version rather than the freebie version. And this is where you can export data to Excel and also import data from an Excel. I showed a version of this in one of my earlier CPD seminars. So when we're doing the load span matrix, if you look at that, this is where this comes from. And again, not really for dummies, a bit more advanced. And finally, the Math tab. And this is the first tab you'll come across. By default, it usually opens with this tab. And we've got a series of the basic things that you might need. The programming, as I've said, is generally only available for the Prime version as well. And the charts are only available in the Prime version. So here's an example of a chart, which I've shown in a previous CPD seminar. It's like a plot, but it just gives you a bit more control over the formatting and the display of the chart, which is kind of quite nice. It's more presentation-wise than the plot. Some tricks and tips. I mean, the first tip you need to know is set your units to the units you want. So if you are in New Zealand, Australia, I suggest you set it to the SI system. Otherwise, you'll get rather confused with imperial systems. I've said it several times before. One of the main advantages of Mathcad is how it handles units. So you can switch between the units and you can put in your input in imperial units, because many old drawings are imperial units, and then it will display and calculate in the SI units, and we'll show that in a minute. So to define a unit, you can type in one useful unit in structural engineering is kilonewton meters, rather than writing out as kilonewtons times meters, because this is a derived unit. And I'll show you that again in a minute. But it comes under labels on the home screen. So let's go live. So this is the Express version, and as you see, some of the tools and capability of Mathcad is quite limited. So in your text formatting, there's no spell checker, and in your calculation, there's no redefinition warnings and so on as well. But you can do some basic calculations as well, and one of them is how you define the units. So let's begin with that example. So let's call it a kilonewton meter, and we'll assign that. To assign it, you press the colon button, and that is equal to 1 kilonewton times a meter. So Mathcad knows what a kilonewton is, it knows what a meter is. So it's recognized those as units, but it hasn't recognized that as a unit. So I'm going to change it from being a variable to being a unit. And now you can use that unit as you see fit. The units itself, it will tell you all the kinds of base units it knows about. Those are all the built-in base units as well. So by default, what you see is what you get. It will open up with the page presentation view. So it's like a print preview. So if we say, let's call L equal to, I don't know, 8 meters, it knows what a meter is. And it will call W is equal to, I don't know, 20 kilonewtons per meter. Let's say our M is equal to, by pressing the colon button, and we'll go W times L. To get to the squared, it's the caret key at the top. Then WL squared, I'm going to stick an 8 on it, so we're looking at a simply supported beam. And it'll tell you it's joules, because the equivalent unit resolves into joules. Highlight the J and type in KNM, give me kilonewton meters. It then reformats it to a more sensible number. And on we go. So there is a difference between the equals and the assign. So you press the colon to get the assign. You're assigning a formula to a variable, and then you're equating that variable to the answer. And similarly, you can repeat that so it knows what m is now. And all I need to do is say equal, and it tells me it's, it should tell me it's 160 kilonewton meters, but because it's using the default raw units, let's change that to kilonewton meters in there. And you can do basic mathematics with it as you see fit. So you use the asterisk key for the multiplier and type in away and off you go. So by default it's come back as newtons. Well, let's have it as kilonewtons if we want. So 160 kilonewtons in that case. So that's the basics of the math. So you can, as soon as you start typing in, it assumes you want to write an equation. However, if you want to write text, you want to put in a text block or a text box. So put your cursor in the page and you can put in text block, and that will go right across the screen and you type away as normal. That takes up the whole of the width of the page. If you want something smaller, use a text block and go with a text block, and you can resize that and reformat it. To reformat it, select it, go into your text formatting. I don't want Tahoma, for example. Let's say I have no idea what sticker small is, but that's what it looks like. And let's have it bigger if we want. If it overlaps, then stretch it. Now, in terms of math formatting, you can set the maths formatting for the whole page without selecting any of them. And you've got, again, different styles to go into your maths equations. Or if you just select one, it will do it for that particular one. Okay, you can also highlight it and color it if you really want. Change the color as you see fit. Now, the latest version of Mathcad is Mathcad 10, which I have downloaded and installed, but haven't transferred the license across yet. One of the things that can do, so I'm told, is do conditional formatting, which is rather nice. So you can code it green for good and red for not so good as well. So that's the basics of inputting data, inputting equations into Mathcad. Other tips and tricks, there are lots of constants in Mathcad. So come back here, you will notice you've already got a number of constants. So if you type in pi, it will give you 3.142 in that case. You want to format it, you can make it bigger, have more and more decimal places. You can change the style if you so wish of them. Where we also get confused, of course, G is a constant and C is also a constant, and rather large one. So that's given it into particular style. We call it a scientific style. But more conveniently for us often is the engineering style as well. So times 10 to the 6 or 10 to the 3 and so on. So that gives you a kilo, mega and giga units that you might require. So you've got to be careful when you're using symbols as variables that have already been defined by Mathcad. But if I now say C is equal to 10 meters, for example, you've now overwritten that value of C. So when I come back, say C equals, it will use that value rather than that value. Many of our equations, many of our equations in engineering are Greek. So back onto your Math tab, you have a symbols button, which is full of Greek. So if I go sigma And one way to differentiate different variables is to put subscripts. The shortcut for subscripts is Control minus, and that does the subscript. So, and you can assign that to 52 MPa, for example. The superscripts, as I've said, can be found using the caret or circumflex character at the top. Shift 6 gets you to the circumflex character. So here's one I prepared earlier. This is Mathcad 9 Prime, and I've opened a template. And this is a template I prepared many years ago and brought forward. So again, in the document tab, you set it up as A4. You want to show the grid. And in this case, you can show the major grid lines, again, a premium feature. So that makes it look more like a calculation page, calculation pad. So what we're seeing is the page presentation view, or the print view. If we go into the draft view, we just get one very large sheet of graph paper, and you've got another area. The faint dotted line there differentiates between the two sides of your draft. So this is the area on the left that will be presented in your calculations. This area on the right, it doesn't print. So you can put in annotation, images, lookup tables as you see fit on that side. So coming back to the page presentation view, we've got a header. And how do we get the header? Well, you've got header and footer buttons on the document tab. So I've put the background in as an image, and to do that, you can come back to the math and put in, click on image, and you browse for an image wherever you see fit, and that will put it in. And the background there is an image, the rest are pieces of text boxes. So one text box, two text boxes, three text boxes. You can also add components of the page in the same way you can do for Word and Excel and so on. So if we come back to our document, you'll see you've got page number and how you can present your page number as a number of pages, or remove it. And you can insert the date as well. So save date, whatever have you. We've also got a footer. In this case, I've just filled it with text images. But you can put in other things as well, things like the file name and file path, and so on. So that's one version. For the people in Redco, I created a Redco spreadsheet. Again, the header and footer are inserted. You've got the standard background, and the rest is put in as text boxes. And our calcs don't have footers, so we didn't put one in. You can put in a footer if you want by saying, let's have the file path followed by the file name. Okay, and perhaps even the saved date. I want the English version as well. So coming back, close that. Coming back to the text formatting, don't forget to reset your language to English New Zealand. You'll have the aluminium paradigm going on. And don't forget to switch on the spell checker. So if you start typing in, the shortcut for text is Control-T. Type away, and it's red squiggles underneath because it can't recognize that word. So you're actually putting a real word, it knows what it is. Okay, so that's as far as I want to go on the basics at the moment. So before we go to questions, just a reminder of what our next seminar will be. Be back to more regular CPD seminars for structural engineers. It's the design of aluminium portal frames. So we'll be looking at the Australian and New Zealand code 1664, how we've actually managed to calculate the capacity of these aluminium sections. Just a reminder of the website and the YouTube channel. The three themes on the channel. One of them is the Mathcad for structural engineers, and we go through many of the calculations that are associated with the CPD seminars I did for structural engineers. So we look at the calculations for the wind analysis and the portal frames and so on. The design of piles using the Hiley formula is remarkably popular. Also, just a reminder, the number of people watching is quite large, but the number of people subscribing is tiny. So 90% of the viewers are not subscribers. Now, it would be nice if you would subscribe to the channel and tell your friends about it, leave a comment, and obviously hit the like button. So for more detailed calculations, you can have a look at the Mathcad for Structural Engineers playlist.